Imagine being given a series of samples with varying concentrations. Without knowing anything about these samples, it would be nearly impossible to derive its concentration. But we can actually use a strange property of light to help us figure out the concentration of these samples. This is called the Beer-Lambert law. It allows us to compare the absorbance with the absorptivity of the dye, its path length, and the concentration to allow us to denote different values based on the absorbance. So for instance, if we have the absorbance, we know how much light the chemical is going to absorb at that frequency, and the path length that light takes, we can use those values to calculate the concentration of the sample. We do this by using a spectrophotometer, in which a light source is split into its appropriate wavelengths. A wavelength is selected. That wavelength is passed through our sample in a cuvette, which is then processed by a photoresistor, and that gives us our absorbance value. The first step in preparing to use the spectrophotometer is to load our samples into cuvettes. Each dilution was added into a cuvette to the fill line. We also prepared a blank to use later. First, we load our blank, which is ammonia, into the mass spectrophotometer, which allows us to zero out the machine. Next, we take one of our dilutions and place it into the mass spectrometer after cleaning both sides with a chem wipe. Then we took a broad spectrum from 200 to 800 nanometer range to allow us to calculate our lambda max. Lambda max is simply the wavelength which shows the highest absorbance. Next, with that wavelength selected, we loaded each of our dilutions into the spectrophotometer to calculate their absorbance. Here you can see our absorbance readouts for each of our dilutions. Next, we took our absorbance values for each of our samples and plugged it into the law. This allowed us to calculate our concentrations.